Chapter 23, generic algorithm and operator overloading. Okay. What's important for this talk is we talk about object-oriented programming. So basically, we talk about how to create a class. And then after we create a class, say we have a class person, right? And we have a class called student, right? And we have a class called called staff, right? And then we have class called high school student, and also we have a class called college student, and we have teacher, and we have something called technician, whatever. Okay, and this part actually we talk about the so-called polymorphism about abstract class, abstract method, and dynamic linking method. Dynamic linking method, you actually use a virtual. Okay, so there will be a definition for get GPA over here, and they may be overridden by high school student. So that would be actually overridden. So this is actually an overridden function. Is actually using the virtual function for overriding. Overriding happen in where? In different class. And then same function name. Same function name, same parameter list, but different class. But it actually is the same function defined in the parent and the children. We use a virtual. And the abstract class is something like, okay, get age. That has no definition over in the person. So we use the virtual equal 0. But you will get the get age definition in your staff. I think last time using person now, but it's okay. And then for student, you also have to get age, right? But that actually is a virtual function, but equal 0, that's an abstract function. And normal dynamic linking function actually it's not equal 0, but it will have different implementation on the parent class and the children class. So this type of polymorphism, we call it overriding. And it's also called polymorphic methods. It's also called polymorphic methods. Okay, basically we design a method that operate on a group of students, but those students may be of different kind, or you operate on a group of person, but those person may be different kind of person. And that actually is a polymorphism by inheritance. That actually is a polymorphism over inheritance structure. So same thing in Java we have object class, and then every object class it comes with a toString function and come with equals. Those functions actually are overridden by some subclass. But once you operate on an array of objects, that actually is fine. You can operate on all of the function that has that. So this one actually is, you can say it is a hierarchical inherited polymorphism, or you can call it polymorphic methods. Okay, that's one type of the polymorphism. You operate on a group of data that has different data type, but you actually have a group using the abstract class or interface to achieve that. Okay, and there's another type of the polymorphism right here we are going to talk about. It's actually called overloading. Overloading is different from overriding. What is overloading? Overloading is not overriding. Overriding is subclass, so different class, but same function name, same function signature. Here, overloading is same class, maybe same class, but different function. Okay, so for example, in math function class, I have something called maxima. But the maxima I can operate on integer, or I can find the maximum between double and double, two double value. That's fine. So these two are considered to be two different functions because the method signature are different. But in a way that if I actually calculate maximum, this maximum function can operate on different data type. Okay, so that's actually is an overloading type of generic programming, right? But we actually this type of generic programming is called overloading, right? But there is another type of generic overloading. More better is using template. And template you can use a type name. And last time we talked about a generic with generic function, generic function, and then generic what's that? Generic container, and then generic iterator. So somebody's overloading is similar to generic function, and it actually is older technique. So generic function actually we use the type name and then define an integer. Maybe you can actually do sort of integer type as a generic function using template function, right? But here actually we are talking about sorting of integer array or a sorting of double array. That's by overloading. But each time if you define it, it has a solid method only working for that one. So whenever you write one function overriding the other,
So
overloading the other.
Overloading is just different types going in.
Usually it's of different type.
Overriding is like if I had like integer and double, two things inside instead of one. Is that right?
Overriding is not like that. Overriding is like you actually say you sort on person. But a person actually can be high school student, can be a person array, and it can be high school student, can be a staff, or can be a teacher. You know what I'm saying? That's overriding. Overriding means that you override the program. The function already been overriding. Overloading means I overuse the sort function. Is that okay? Reuse. Overloading means reuse the function name. Right? Loading on the function name. And then it operates on different function data type. But overriding is like
and can I use so overloading works also if I use like different types too? Like two different parameters?
Yeah, but you need to write two functions.
Yeah, but I can do sort double comma int, right? Two parameters inside if I wanted to, right?
Yeah.
That's still overloading, right?
Yeah, it's still over. You can actually do if not this, if actually maximum you have int and double. You finding the maximum between int and double. That's also okay.
I can also do max int double, right? Three numbers.
Yeah. Actually, four combination int, double, int, double. They are considered four different functions. But the thing is that this actually is not that great. It's not that great. Why? Because overloading actually you need to rewrite the function, so it actually takes more time to write all the functions. You know what I'm saying? Actually, it takes more time to rewrite the function, so it usually take more time to develop the overloading function. But generic temporary function is actually better sometimes because generic will give you more of the data type. As long as you define different data types, say max function, you find a max function, and that max function right now you operate on T or something, right? And actually this T you can always actually operate on T function, say A and TB, right? And as long as you actually assign it integer or double, it can always work, right? Is that okay? So generic temperate type or temperate type or the temperate container or temperate function actually is a better way to do that. Now more welcome that way. You know what I'm saying? But that's actually called parametric polymorphism because you use the type as a parameter that to be passed into the function. Okay, but the kind of the overloading is different. Overloading is that I have an operator plus, and I have A and B. I try to redesign the function plus. But each data type, say integer, I need to define one plus. Double, I need to define one plus. String, I need to redefine the plus. But the plus will be defined for different meaning at a different location. You know what I'm saying? But you actually need to do that. You actually need to do that. Otherwise, you can actually you can actually use it efficiently. Let me go back to my slides. Okay. Okay. Now we finished a few updates. So right here we have generic algorithm. Generic algorithm are algorithms in which actions and steps are defined, but the data type can be changed. And generic algorithm right here, we have two ways of doing generic algorithm. One is to use temperate functions. So at the compile time, I actually assign my max to operate on integer or integer or double, right? Or a class, say I have a stack, then I declare it's a stack of integer, right? This is called generic by using template function or template containers or template iterators. But there is another way we use this overloading idea. So overloading idea means you have the max function, and then you need to write a implementation for int, or another implementation for double, or string, something like that. This is called overloading. So let's look at the difference between these two. So right here we have try to print integer. So we need to write the print int as a function, and if we had float or double, we need to write 3 different functions. So in a way, if this function is just a print function, I would suggest to use a template would be easier. Is that okay? But these 3 actually are considered to be overloading if you actually take away the int. You know, right here it actually has put a name, but if print character, print double, print float, you take out the name, it's called overloading. So the print function I overloaded 4 times. Is that okay? But in fact, these are 4 functions of the same functionality. You just print something. Okay? So function overloading. Function overloading is the use of the same name for different functions. Different function means you are using different parameter list, distinguished by the parameter list. And the function name and parameter list combined is called a function signature or method signature. So in a way, they are different functions. And the overriding, if you actually get age, that actually is the same function. the same function, same signature. It just defined different way in different classes, your parent class or subclasses. That's called overriding. And here we call it overloading. Loading means that we load more function into the operator, plus or minus. So eliminate the need to come up with many different names for identical tasks. Reduce the chance of unexpected results caused by using wrong function name. So basically, with the function overloading, the print character, print string, print whatever, I can always just use the name print, so I won't get confused. And I don't need to have several names, but we just use the same name. So for example, like the function toString, usually we use the toString for different class. And in a way, it's also a sort of the so-called overloading, because we overload the toString. So the toString actually is of the same name. But the toString, because C++ doesn't have the toString function in the object class, so it actually is called overloaded. But if the toString function in Java, it has the same definition in the object class, then it becomes an overriding. So somewhat these two methods of different language, it can be of different combinations. So now the print function, we can write a print function for integer, for character, for print, for double, for float. So that's called function overloading. Is this okay so far? Hello, Eric? Yeah?
Yes.
Okay. So that's what is called overloading. Function template. Function template in a way is different and more welcome right now, because C++ language construct allow a compiler to generate multiple versions of functions as long as you provide the integer or double in there. The compiler will provide several versions of the function for you, and at the time that you do compilation, the compiler will recognize and assign the type to the function using the function template. So template is a template of function, and then it actually will accept some parameter, and that parameter actually is a data type. And using that data type, in the compile time, it determines a certain function type, and then you actually override that function, overload that function, and then you basically can call the same function for different data type, but actually those functions are of different data type, and they are considered to be different functions. But template is a function. Template is used to generate multiple functions at the same time. Is that okay? So that's called function template. That's why it's called function template, because it's used to build functions of the same name of different type at only one statement. And it actually is determined at the compile time. It actually is determined at the compile time to decide what data type to be used. Is that okay?
Yeah.
Okay. So the next one. So there are two class parameter declaration. You can use class or type name, and in principle that doesn't have much difference in C++. So that actually no need to worry about a type name or class. That actually not much difference. So you can use class and some type, or you can use some type and then val. Okay, so you actually here you can have the type. So here is actually type T, some type, class T, or type name T, and then put T and then value. So I like the Java way of using T or E. That would be easier. Okay, so this is sometimes you can use a type T. So this is called template parameter, or sometimes we call this one parameter variable. So it's kind of like a variable. This one we call it type variable. And the variable is decided at the compile time. So basically, you can put an integer over here, so it becomes integer print function. You can put a character over there. So that character or integer matching the type. So it's just like T equals integer, something like that. And that integer will be determine at the compile time to put the type over there to compile it. Is that okay? But if you put different integer or character or flow, it actually just like create 3 different functions. Okay, but usually when we use C++, we don't see print int, print character, or print flow over there. As long as you put this, it actually nothing like that. Why? Because this one actually in C++, we actually never write a T over there. We seldom write a T over here because this one actually can be determined by putting this one over there. So it becomes a print T val, right? So this one actually can be omitted. So in fact, you just do print and then sum. And because sum is actually integer type, so it actually will call something called print in type. Okay, in compilation time, it will be determined. You just write this template for function. Is that okay? Let's call implicit template arguments. Implicit template argument. Is that okay? So you can have, and you can actually have multiple argument lists. That's possible. T, S, and whatever. So when a compiler instantiates the template, it substitutes the template arguments for template parameters throughout the function template. Okay, and you actually can do implicit. Okay, this one important, implicit. And then enhance the print template. Okay, we got this, and actually I have string and some type. So here is a T. You can put some other things over there, not configured by the template type. It's fine. So that actually is okay. And then generic function, function overload, and template function. These are 3 different concepts. 3 different concepts. Okay, so function overloading, we know it. Okay, different function definition, same function name. So it's a maximum integer, maximum double. Okay, that's a function overloading. Template function, we know it. It's called one function definition, and then compiler generate individual function for you, right? The last one is called generic function, different function name and different function name and different definition. It's just like you print the character, those type of things. But in fact, this generic function is implemented, can be easily implemented by function overloading or template functions. Is that okay?
Can you explain generic functions again?
It's so easy. It's just like you had a print int, print child. These are function of different definition and different name. Okay. And go to here, it become print, right? Integer, right? And print character, right? And over here, it become print int.
Generic function. Oh, okay.
That's okay? What I
usually write.
Yeah.
Okay.
But overall, all of these can be called generic programming. Is that okay? Nowadays, all of these called generic programming. Is that okay? All of these now called generic programming. So template is one kind of generic function as well. Function overloading is also a kind of generic function as well. Is that okay? It's a subgroup for this. These two are this one and this one are subgroup for this generic function. So user-defined specialization say we have a template, but no parameter. Let's see, and what's this for? This is the demonstration of this one without parameter. So here actually we have print name, whatever name of the variable, value of the variable. Here has a status type. So here, actually, this one should be the status type should be put over here. I'm serious. I think here the template should have the status type. Okay, let's assume that it's a status type. So the value actually is belong to that type. Okay, so the val actually used for switch. Okay, so this one actually can be used for different data type to do switching. Organizational program call, three possibility. Template definition at the beginning of a program prior to main function is one way. Second, function prototype first, and then main function, and then template definition, and then template defined in header file. Actually, these are all okay. So personally, I prefer the template before the beginning of the file, or the last one, template defined in header file. And template definition in the header file is used for class. Template definition at the beginning of the file prior to main function is the generic function of for no class. Well, what is the generic function for no class? Like the one we do it, or sometimes we call it generic global generic function. The first one, like max, right? Max integer, right? So actually we can do template, and then type name t, and then we do max tt. So that's a generic function and put in ahead of a main function, right? But this template doesn't belong to any class. So that's the first one we say okay. Second one, you can put a prototype over here and then move that down there. This one, I don't encourage that. Third one, you can have a template function definition, and then actually you put into a class. For example, like the little toString function, right? Sometimes we put into like class arrays, for example, and that toString function is, that array function may be accepting different type t, right? And the data type is always changing. So I can put that toString function that actually can be accepting all the type. You know what I'm saying? And that actually is a template function included in the header file. Is that okay, this part? Hello?
Yeah.
Generic data type. So what is the generic data type? It's the type for which operations are defined, but the data type or the item being manipulated are not. Okay, so in CW's language construct that allows the compiler to generate multiple versions of class by allowing parameterized data type. So this one is to the class template is used to generate a class, a multiple class using one class definition. So it actually is like class template, right? Type define t, and class whatever array or something t, and you can set that t over there, okay? And then you can have the, say, private, and then do array of t, something like that, okay? That we call it parameterized, because at compile time when you say stat and then integer, so that parameter be matched to t. That parameter int be matched to t. So assign the value int to t, and then it generate one class. Assign a parameter actually double, it create another class. So here we have a class template. So within this class template, actually we can assign a glist, general list, and here we put integer. That it will be a list of integer, and the data will be integer type. So if we actually right here we assign general list, generic list, double, and actually here it replaced by double. So, but this is one class. This is another class. These two classes are two different classes. Is that okay? These two classes are two different classes.
Can I just write T for item type?
What?
Is it possible to just write T for item type?
Yeah. You can use E or T or whatever.
Okay.
That's up to you. It's a variable. It's a variable. It's a parameter. It's a so-called type of variable. But that type of variable is determined at the compile time. A compile time, when somebody calls glist int or glist double, is determined at compile time. It's a variable. It's something you can substitute. Is that okay? So right here, just like this, it actually creates three possible classes. It actually creates three possible classes: int, float, and string. Right? Now the question is, can you generate something called, something called array of person, an array of student, an array of personnel? Okay, my question is, these three classes has some sort of inheritance structure, right? No matter what inheritance structure it is.
Yeah.
Right? Well, but are these actually related?
All else.
Just like you have array person, and then you have array student. I mean, you have array personnel. Yes or no?
I'm gonna say no because you said before that they're all different classes.
Yeah, you're right. No way. Why no way? This person may have a get GPA, right? So they have inheritance structure like get GPA or get age, right? But array is a different class. Array has its own method. You can write some array, a generic class that has inheritance structure, but not these three. You can write some say a node. I mean a node list. Say I have a list, and then there's a linked list. Okay, list of integer type, and then linked list of integer type. These two can have inheritance structure, yes, but not array of person, array of student, array of personnel. You know what I'm saying? Because they don't share the function. They don't extend each other. You know what I'm saying? You know the difference? Say I have a list, right? Originally I have a list, and my linked list actually inherit the list. Is that okay? That's fine, right?
Yeah.
And now if I put an integer, and here I put integer and make both of them as templates. Is that okay? That's okay. That actually you can write it in a way that they have inheritance structure. But actually these two are all different class type. And they will maintain some inheritance structure by using the right inheritance code. Okay, but right here you don't get the inheritance because you are array person, or you are array student, or you are array personnel. These three are of different classes. And array. There's no inheritance structure. So the left-hand side, these are the same, but they has inheritance structure by list and linked list. Here are the same, but the data have the inheritance structure, nothing to do with the array. Is that okay? Is that okay?
Yes.
So basically, let me describe this. Say here you have template and G list, right? And it's possible that I can actually inherit a say for example, I inherit a list. So I can basically write here that it actually inherit a list. Is that okay? It's okay, right? So then at that time, that list of integer and the G list of integer, two are actually has the inheritance structure. Is that okay? Is that okay?
Yes.
But the array itself, you put into say right here, if I have these two has generic the inheritance structure, but G list of person and the G list of student Sorry, no inheritance structure because your P, actually your S inherited P, but G list and G list P and G list S no inheritance structure because it actually is a of different template. And in the runtime, they actually expanded by compiler. These two classes have no relationship, right? But the GList and list, actually, I write it with the inheritance. That has the inheritance structure. So at compile time, it actually will expand and they will follow the inheritance structure. Okay, so class template argument must be explicit. Okay, the compiler generate distinct class type called template classes and generate classes. So at that time, after you generated GList double or GList integer, they are already two different classes of no relationship, unless that your GList and list two different generic container, but they have the inheritance structure when you write the templates. Okay, when you instantiate a template, a compiler substitute the template argument for the template argument throughout the class template. Okay. So right here, these are all replaced by integer that we know. Writing the function template. So here we actually write. So here something is like when you write this one, everywhere in your implementation, you have to write this. The class now is actually called glist T. It's no longer glist, it's glist T. Is that okay? So it will be substituted by flow. It will be substituted by flow. Is that okay? Is that okay so far?
Yes.
The organizational program call, actually, a compiler must know the argument to the templates in order to generate a function template, and this argument is loaded in the client code. Client code is the driver. So your main function would need to know the type and then pass it, and then that data code will pass to, say, array, template array, an array of integer type that actually will pass over there. Okay, but main function or client function or driver function need to know about the type. Solution have specification file, including the implementation file. Combine the specification file and implementation into one file. So usually you would like to have the whole template right into one .h file. That would be easier. Warning, are you using an IDE where the editor compiler link bundle into one application? Remember, the compiler must know about the template argument. Okay, these are just okay. Okay, now we finish that template discussion. The next one is operator overloading. Okay, operator overloading is to use operator with object. So operator overloading. So what, for example, like we know what plus is, right? But if we actually have the polynomial 1 plus polynomial 2, this one we don't have definition because this one we would like to become a function called operator plus P1 and P2, right? Two parameters. We will convert to that function. So to convert to that function, we call overloading. So basically, this one plus is similar to a function called add, and then two parameters A and B, right? And this one actually can be used for integer, can be used for double, right? The same add name. And now I want it to be add and then provide polynomial, right? And use that to overload that plus sign. Is that okay? But operators overloading actually is a standard name, like left double left shift, big Y left shift, or string insertion. Or this one plus that actually perform arithmetic on multiple items. So fundamental of the operator overloading. Using operator on a class, it must overload for that class. So if you want to have poly, you want to use the add operator. Now you need to overload for that class. Otherwise, you cannot use it. So basically, you have the assignment, you have the ages, you have the comma. Okay, so like A equals B. This one's the assignment. It actually become operator equals AB. Is that okay? An operator equals actually is a function. It determines the operation for this A equals B. For example, both A and B are polynomial function A and B. Is that okay, Eric?
Yes.
And this function actually is to assign B to A, right? Assign B to A, right? This function actually is assign B to A. And usually you will have these S signs being put on the left. Why? Why it always has a S sign being assigned to the left? Because A equals B and later A will be used to what? To accept some other value. So if you just know S sign and you return an A, right? A value for A, that A actually is what? It cannot be updated later. Is that okay?
Because A is just a value, it's not a address.
If you don't have the alias sign, it's just a value. Yes, you cannot update.
Okay.
You know what I'm saying? So for something like when you overload some operator like this one, like A is equal B, this operator, for sure your A need to be working on left hand side. So you need to have left hand side value. For example, A of I, this one, right? This one is also an operator, right? Right? So basically you have the operator X and Y, right? And this Y actually is the integer, right? Right? This is bracket, okay? Is that okay? And this X is A. So usually you will have two things you need to implement. One with this, one without. Why? Why one with, one without? Because your A of I can sometimes use as a right hand side value, sometimes use as a left hand side value. Is that okay? So when you actually use,
so if you don't want to update, you can just do operator.
Yeah. So basically this one return the left hand side value.
Okay.
So you can put on the left hand side. And this one actually use for the right hand side value. It just provide value for B. So you will return 5, say. Some value 3 or 5. And assign that to B. Is that okay? Is that okay?
Yes.
And also if I have the A, say student, right? Student, I have A array. I have student A array of 10, right? Someone is an array of 10. And I actually have this left-hand side value, and I want to do like the GPA, right? If I try to assign some function, overload some function, and I will assign to, say AI equals, equals B or something, like I want to get this alias value. At that time, this one usually also need to be left-hand side value because you need to use that as an object to get GPA. So that also need to be a left-hand side value. Is that okay? So comma is to evaluate expression to the left, then the expression to the right, and return the value. So actually, this is a two-way binary operator with comma. So you actually can overload different things for this. So overload loading provide concise notation. So basically, original you can use like object 2 equals object 1 add object 2. Now you can write object 2 equals object 2 plus object 1. Is that okay? Is that okay?
Yeah.
And these are something you need to know. Some restriction on operator overloading. You cannot change the precedence of operator. So plus sign behind multiplication, that's always true. Okay. So number of operands you cannot change. You cannot change the number of operands. The left to right associativity you cannot change. So basically, when you do this, A, it actually is considered to be like a function called operator then, and then you have this one, A. Okay, so that A actually will be this one, right? And whenever you do this, this actually is just like this. It will be written like this. Okay, so it won't become this. No, there's no way you write this to work. Is that okay? That's called associativity. Associativity like A plus B, right, times C, right? You associate with the left-hand side first. This one will take priority than the plus side. No matter it's for integer or for polynomial, it has the same order. Okay, is that okay? And some built-in data type like plus or something, you cannot actually override it for polynomial. If we define plus, it will be defined as plus. Okay, and some built-in data type like integer, you cannot change the integer addition. Okay, cannot create new operator. Those operators are basic one, plus sign. You cannot say, this time I just want to create a new operator called this operator. I want to create a triple column. No, there is no something like this. No definition for this. The only operator you can use is the one in table. And then this one and this one and this one are considered to be three functions. They need to be overloaded separately. So there is no way that I define plus and define equal, and then I get the definition of plus equal. No, that's totally different operator. Is that okay?
Yes.
Conditional statement, no overloading. Ternary operator, no overloading. Okay, so here are a few rules you need to remember. The precedence of operator will keep. Associativity, no change. Number of operators, operand are kept. 1 is 1, 2 is 2, 3 is 3. Then built-in data type, no change. Cannot create new operators. And then overload plus equals cannot create an overloading for plus equal. Okay? That's the basic rule. And here are the operators that you actually can be overloaded. Here are the operators that you can use to overload it. Again, here the 4 are something you cannot overload. So for example, like dot. Dot is the data field selector. You cannot use it. Dot star is wildcard type. You cannot overload it. So here we have 4. You cannot overload it. Other than that, anything up here can be overloaded. And when you want to overload it, you write operator and then the symbol, it will be defined. So software engineering observation, at least one argument or operator function must be object or reference of user-defined type. So basically, at least you have plus, right? A plus B. So at least one of it must be the object type. So polynomial can add with integer, but an integer can add with polynomial. Or polynomial plus with polynomial. These are fine. But integer plus integer, that cannot be overloaded because this guy actually is fixed. Is that okay? So the two operands, and then the two operand A plus B actually will become operator plus A and B. So it becomes a function, some sort of a function AB. And this one is actually the first parameter. First operand. And then one of it must be a class. And this prevents the programmer from changing how operators work on fundamental type. Assuming that the overloading a operator like plus overload of related operators such as plus equals or that overload the equals or not equals. This actually no, you have to redefine them, okay? An operator can be overloaded explicitly, and there is no implicit overloading. So there is nothing like I didn't define it and you will overload for me. No way. Okay. So now something funny here already. Operator class member and of non-member. Okay, now what's going on over here? We have operator function, we have plus sign, something like that, and then we would like to overload it, right? So you have two ways to write a function. One is called member function. One is called global function. Two ways you can write it. Okay, actually there are three ways you can write it. These are two related to a class. These two are related to the class. Okay, there are three ways you can relate it to a class. Now let's do this. Okay, the first one, three way. Let's talk about global function. What is global function? Say, I have some function called toString G. So I put my string over here, right? And X. So this function actually is a void type, right? I'm sorry, string type. And let's assume here it actually is like, I'm sorry, here let's put student, okay? Don't put the string. So my string Y will be converted to string. That is called global function. And it doesn't need to be put into some class student. We don't put into the class student and it is outside and you accept the student and then you convert it to string. This one is fine. That's the first way we can actually write. It's called global function. Is that okay?
Yeah.
So this is just a normal function, nothing to talk about. Okay, so this one actually, I think it's okay, nothing to talk about. And here, as the member function and as a global function, we talk about the global function part now. Second one, now we are going to deal with the member function and friendship function. Okay, that become interesting now. Member function we know. So we have a string. I'm sorry, student A, right? And we can do C out A that toString, right? And because what? Because in our class student, inside here, we actually have the define of the toString.
So my teacher likes to use to change the outstream. Is that a better way to do it instead of the toString?
Or whatever, it's okay. It's okay.
Okay.
Okay, don't, it's just the function name. It's actually okay. Is that okay? So this one is a member function belonging to the class student, right? And the previous one we talked about is a global function. You put outside of a class, but you handle on the student data type. Is that okay? Is that okay?
Yeah.
Okay, now let's talk about the third type. Let me finish this third type and then go back to discuss your question. Okay. Third type is the friendship function. And what does this do? Class, okay. Student, okay. And instead of using a.toString, right? And actually right here, I can write something called friendship function, okay? And then here, say I have a friend, friendship function, print string. And here you accept string type, a student type, S. And I will print out that and then return as a string type outside, right? Okay, so this student S has nothing to do with my A student, right? Because it's actually put it in the class, right? But it's also different from the outside string and toString. Okay, you can also call it to print the string, whatever. And then student X, right? That's called global function. And what is the difference between the friendship function and this one called global function? What's the difference? How come we like to
use private or protected data?
Yeah, friendship function can print the private or protected data. What does that mean?
Use the private data in the class.
Because this friendship function you put into the class. So, for example, I have an x private x. That one I can actually print x is okay. But if you are in the student class, can you do x dot something? No way. You have to use a get something. So that's more complicated. Is that okay?
Yeah.
So that's why the friendship function put into it. But friendship function, in a way, is similar to the global function. Similar to the global function. It has nothing to do with the current object. And it's more like a class method.
So if I'm gonna use it in my main function, do I just call toString? That's it. You don't have to use the object s dot toString, or do I have to do string class double colon and then the method?
You need to use the student class double colon.
Okay.
So let's try this one. Okay, let's try this one. Let's try this one. Let's try here if we have something called student, right? And let's put student over here. Okay. Oh, this is a man. I'm sorry. This is a man. That's okay. So here I have the username space. std, right? This is fine. And inside my class over here, I generate a new file called student. I'm sorry. Here, let me save us. Student. And let me change it to .h file. And I don't want to write a dot. Because I want to make it simple. So I don't actually want to use the .cpp file. Okay, I write down something like this, right? So here I say class student and then I keep this, right? So right here, let me just do something. I have a public section. And I have a student. And here I have, say, string name, right? And here I have private data field, and it only has a string name. Okay, that's the only thing I have. Okay, I don't want to make it too complicated. So I need to include string. And I also include the so-called as a string, right? Okay, now I have this, right? Now, first one, I can actually write here as a global function. So I can just string, right? And then toString 1, right? So here I actually do student, okay, S, okay. And then what? And then over here, if I don't have any way of getting the data, actually this one is a global function. You cannot access the private data field, right? So here I can only do like return get name, right? If I don't have a get name, it actually don't work, right? So here I should have a string get name, right? Is that okay?
Yeah.
Yeah, okay so far? Okay. Then I go back to my main function, and right here I just say student Let's try this one. Okay, actually it doesn't has the here it actually, oh, I'm sorry, here it doesn't include the student h. Okay, compile. Okay, toString, what's wrong with the toString? Okay, that's not allowed. Get name, so no matching call. So expected this one. So what is this time? This time is expected parenthesis before n. Expected the student string n. Expected parenthesis before n. What's that? String does not name a type. Oh, okay, I see what's wrong. Nothing wrong. Let me compile again. Okay. Okay, now what's that? You will not declare this scope. Okay. Why this one doesn't work? The class is behind it, right? So what should I do now? Under this situation, I know before I try to compile, I know here it will create trouble because if I put it as a global, it will create trouble. Student was not declared this scope.
Just put it in the class.
No, that actually become member function. So the right solution is to declare a data prototype, class prototype. Is that okay? Is that okay? That actually will pass. Now, second one. Student H. Oh, okay, here I have something wrong, okay? And then here, the student one, and define the student. The file included a string to string one student. So it will get name to string one is not called actually. So here I have A, right? But I don't have anything to do that. So I just do to string one. Is that okay? So let me actually save all. So now S has an incomplete data type. So actually it's not been declared yet. So how about I move it down? Okay. How about I move it down over here? Okay, and then this is probably not a good way to write it. I know it may work, but it actually may not work. So get name is not declared in scope. Okay, so here I should have s.get name, right? So that's fine. That's actually nothing wrong. Okay, so this one, what's that? What's the problem now? There's a linking problem. Undefined reference to student get name. Okay, I'm closing. I pass the student over. I pass the student over, right? I pass the student A over, and then student get name. Undefined reference to student get name. Oh, I'm sorry. Student get name. I don't define anything over here. I'm sorry. It has nobody, so actually it should be return name. Okay. Is that okay?
Yeah.
So what's that? So it's wrong again. Student undefined reference to get name. How comes there's another one called undefined? In the main function, let me actually save all. Okay. No, let me do part reveal. Okay, so that's the reveal problem. Actually, it doesn't reveal everything. So here I print out every child, right? So this one is an example of having a global function. So this one actually is a global function. Okay, this one is a global function. So that actually is a global function. The second one is called string two, right? But this one actually is the same as the get name, but here let's say return name. Okay, so this one actually is the same as get name, but this one is a member function. Okay, this one is a member function, so this one is a member function, right? So this one I actually can do this. Okay, so I have the to string 2. Now I can convert to string 2, right? Okay. Okay, right? But because it's also a member function, so the name is also okay. Third one here, I can do friend to string 3. Now, because this one actually is a friendship function, right? So I put this here. I don't need to do what? I don't need to use the get string. So here I can do return name. Yeah, right? That has two advantages. Okay, that's one advantage over here. That's the first advantage is like I can actually here, let me see here is like this one is called friend function. That's one advantage. So here in my main function, now what should I do? C out, and then what should I do? What I need to do is that student, right? And then here like to string of A. Is that okay? So it's somewhat like a class function in there is somewhat like a Java class function. You know what I'm saying? Somewhat is like a Java class function. So you actually need to put a class name over here. Here the same thing. It's actually a friendship function, but it don't belong to the class. Doesn't belong to the member. So here I put A in here as a parameter, and pass through here actually you will call it a get a name. That's one advantage. Is like let me see. String 3. I'm sorry, I should put a 3. Okay, that's my fault. I think I just need to reveal the use of student name, non-static data. Integer function to. Oh, I'm sorry. It should be a string type. I'm sorry, I did not specify the data type. So here actually, because this one is considered to be a static function, so it actually is a class function. Okay, so here let me see. Probably you still need to use the get name. Let me see. If the get name, I think it's okay. If use of get name should be okay. Call member cannot call member function. So here I should be this get name. Okay. What's that? Embedded use of this function. Oh, I'm sorry. Should be S get name. So I'm sorry. I haven't get to the right point yet. S3 is not a member function. S3 is not a member function of student. How about it? I do push. Oh, it should be something like this. You don't need to have that specifier. But as long as you operate on the friendship function, it's still somewhat a little bit different from Java. A little bit different from Java.
So friendship and global, you do not need to use the.
Yeah, you do not do the no specifier. So here, what function-wise the same. So, but here actually no specifier. Okay, but somewhat friendship function you can use in that situation. And also another good thing is like this one is the global function, right? It actually is global. So here actually if I have some, I can use this toString function actually also inside my own class. Inside my own class. Instead of defining outside, it actually can also be used in my own class. Is that okay?
Yeah.
So somewhat you can use that more similar to a class function, but because it's a static function, so you require data to be static. Otherwise, you won't get it. Otherwise, you need to use something like that. I did not get it. So actually, say if here I have a static integer student count, okay? And then this one set to 0, right? Initial student count 0. And here actually, I will just say student underline count increase, right? Every time I increase my student count. And here to string, I have a student, I actually return the string plus, I can actually do what? Here, if I write another string function, friend function. So if I have a function called number of students.
For the friend function, why is it s.getName?
What?
Oh, never mind. Okay, for the friend function, can I just do return s.name?
It says I tried it, but actually it's
What did I say?
probably okay. Yeah, probably okay. Yeah, probably okay. Yeah, it should be okay. I'm sorry. It should be okay. Yeah, I probably made a mistake, not because. So let me actually get rid of the student count. I don't need that. Probably okay. Yeah. I think I used name. That probably is error because it's not allowed. Yeah, it's actually okay. Right? So friendship function is quite useful actually. It's used as a utility function. So actually it's like right? Service only for students, but not instant variable, but not instant function. Serve is more like a static class function. Is that okay? And because it's in the same class, so actually you don't need to use get name. The private data field, protect data field, you can actually access it. That's the advantage of putting it right here. And putting it outside, you have to use the get name. Yeah, right. You are correct. Is that
Okay,
okay?
so for the friend function, if I do string to string 3 and then I do like person s and they're like linked together, then do I have to use the person's class's get name, or can I just do s dot name?
I think your parents' class,
If it's inherit.
your parents' class is private. Is private over here. You cannot see your parents' data,
Okay.
right? This one same class because the name is the belong to student, not belonging to person, right? But if the person s dot person, no dot age, no, because s dot person the age belong to if it is defined in the parents, no, no way. You have to use get age. Is that okay?
Yeah.
So this one actually I did it. Okay, I did it. Where it is? So here, yes, another advantage is to okay, that's another one. So here clearly show you three type of different function: instant function, and also global function, and also the friendship function. And global function is the way we standard usage when we write the C program, right? C program has no member function or friendship function, right? Right? C has no member function and no
Hmm.
member function, no friendship function. But here, the difference between friendship function and global function need to be clarified. I believe that some of the function, that's why I like to use a friend instead of global. You know, global sometimes it's quite awkward to use. Some data field you cannot use. Okay? Some data field actually you cannot use it. So we are where we are now. We actually up to 64, but now we are actually in probably here. Yes, 37 or something. Okay, but we will have some class. So here now the next one is to operator function as class and global member. So we can overload this one, right? As the teachers say, and actually it shows us outside function, right? It shows us an outside function, and then it actually global function, and then it actually shows as a internal function as well, as a friendship function as well later. But I believe that using friend function is better for this one. Okay, so now let's try to overload this operator without using your teacher's note. Is that okay? and the right hand side insert or extract. Is okay? So basically we want to print this one to like C type, right? So here, let me write it as a frame function first. Because I'm going to override the function, so here, let me see. The type of data I would like to override should be frame function and all string, right? And then alias operator should be left shift, right? Actually, let me see. Should this one? I want to print it out. Okay, so I have an all string. Okay, so this one actually writing like here should be like out, right? And then here the next one should be my student, and student should be S. Okay, so it's somewhat is a friendship function, but this friendship function is to override. Is to override what? Is to override C out. This one and the student, right? So this one actually become a function called this one, operator function, and then this one is the first parameter here. So it actually is an output string, right? And my student is put over here, right? And an output string because I want to modify it because later I want to output it. So here must be an alias. I want to update it, so it must be an alias. Is that okay?
Mm-hmm.
So here it actually is okay.
Wait, so if you don't know what you want, is it
so
better
here,
to
here
always
you have
write
a,
alias?
No, not doing that. Okay. Here I have something like this, right? So after this operation, this guy belonging to C out. Right? I say that, and then you continue to do this. This one will be again, will create a new bigger C out, right? I talked about this already, right? Is that okay? Last time I talked about this, when your operator, when you actually put your output variable to C out, the output is again C out. Is that okay? And then this C out insert this one, it will become another bigger C out. Is that okay? That's not actually I talked about this before. Is that okay? Is that okay?
Yes.
So this one out definitely need to be able to be updated. So what I will do is actually right here, I will do something like this. Look at this, okay? I think it's the right way to write it should be out, and I put something called S dot name, right? And I return out. So here, what I need to do is I need to have this. Okay. Do you think so? Do you think that this function should be written like this? Your S is just like a two string three, right? Because the friendship, both are friendship functions. So here S dot name is legal,
it looks
right?
like it works.
And then it actually being provided to an output string called out, right? And that one return to outside, and that is actually the C out. So here, if I put C out will be actually it would be what? C out would be the one I would have, right? So let's do this.
Yeah.
So let's do this here. Let's do the first one. Let's do C out A D and DL. Is that okay? Right? Because this actually is the student and the C out, and the C out is the out. Wait, that's the okay, I misspelled it. Yeah, it worked. Is that okay?
Yeah.
Okay, now the next one. This one, I want to have friendship. Okay, tell me what would be the What should I do? Now let me, I'm the robot, typing robot, and you tell me what to do. I want you to do this one.
Okay.
Okay, let me write the interface for you. And I think this one should be iStream. Right? This one, this part is no argument, right? Should be written like this. Okay, now what's next?
So you would do in the two things to the left, s.name, semicolon, return in, semicolon. Yeah.
Okay, let's see. No, I need to reveal. I know I did not wrong it. So here I should have CE. Let me do like a student B. Okay, and then C in to B, right? And C out from B, right? Enter. And here say C out. Right? This should be fine, right? Let's go. What's that? Anything wrong over here? I just add a few things. How come it is spelling and space? Spelling nested should be where error. Let me see. I use the C in student B. I put the output of this. Let me actually first, let me actually comment this out, okay? Because these are the new code I add in. Okay, maybe my code over student has something wrong. Let me see. In string, this one should be fine, right? Nothing special. So here, let me actually do this. Rebuild this. Wait. How comes that I make no change and actually it doesn't work? So here, let me see. Expected at the end of input. At the end of input, expected. Let me see. Let me set all. Let me see. Expected nested whatever. Name not this scope. Wait, how come it's like that? Did I put something wrong? Did I put something wrong? A friendship is outside of class. A friend should be used outside of class. A friendship is used outside of class. A friendship will be used outside of class. What's wrong with that? And reveal. Wait. First one, expected. So actually something wrong inside the student, the edge, okay? Something wrong inside the student, the edge. And here I have it. So probably this one is not okay. Probably this one's not okay. I'm suspecting that this one's not okay.
Then why would it work for out?
Let me see this one. Okay, let me do this one. How about this? How about, let me do this. Character. How about we do this, okay? Don't ask me why, okay? Do you think so? I think should be what? No. Let me see. Should be something called the name is a string, right? The name is a string. So actually name is a string. So actually your name equals buffer. Let me work. Let me see. Error nested before namespace. Where is a namespace? Now, let me comment this out, okay? Let me comment this also now. Because we add this one, right? And it doesn't work, right? It doesn't work. It doesn't work, and then now let's say, oh, we did something wrong and it doesn't work. So it actually now should be clean, but actually it is not, right? Now it should be clean, but it is not. Oh, okay, I know what it is. The parentheses got stolen. You see that? I make a stupid mistake. The curly brace got stolen. Okay, now this one actually, let me restore it. You know what I'm saying? I erased that second curly braces, but it actually the program has not been closed yet. It's okay. We sometimes bump into this. So now before we test that code, let's just do compile. Okay, that's okay. So there's no need to run it. Let me actually unwrap this guy. Okay, let's go. So the problem is I created. Okay, no matching function to call student. No matching function to call student. Oh, okay, so I need something. So how about let me just do empty string. Okay, and run. What's
Oh, your sin can't have spaces.
Sing which one?
Your input can't have spaces, right? That only
Mm,
works for a single string, right?
okay. You actually you need to get line.
Yeah.
You need to use get line. So that's wrong again. Okay, but you actually need to at least print out the Eric. But I don't see it as well. I think
Oh,
two problem.
I think another problem is
Yeah,
go back
your S name is okay. Go.
to main. Oh, because you created an object B, right?
Mm-hmm.
And then how do you
Your name is
input?
not assigned to. I think your name is not assigned to. Somehow your name is not assigned to S name yet. So let's do this. Let's do just do quiz. Right? It doesn't print now, but the data is input now, right? The data now is actually input now, but it's not assigned to your variable S name. So let's go back. Here you have a student called S name, right? You actually get this one. Oh, this one is the local name, right? So what's wrong is this guy is actually local. It's not an alias. So let me put an alias over there. Let's see whether it will work or not. No, it won't work. How about this? How about this? How about this? How about we do this? Okay. Is that okay? And I don't need this anymore. Let's try this one, okay? Still not getting there. Okay, let me actually bring up the one from the assignment. I don't want to waste our time, so let's go there since it's so close. It's so close already, so it doesn't matter that much. What's that? He actually run the read, and the read actually is the input string. So let's look at the CPP one. This one is string. Yeah, you use a buffer, right? You use a buffer, and then you actually, after you get the buffer, you actually need to use that to construct a variable. So that's it. Okay. Now I think the trick is here. This one must be an alias that can be modified, right? So here you should use like character buffer 256. Okay. And then here you do buffer, right? And here instead of having that, you do s equals. Let me see. What did that say? String to list. And assign to head. So the string name need to be updated. String name. String name itself is a string, right? String name itself is a string. So can I do this? Can I do copy assignment? Can I do something called copy assignment like so if you look at the after you do that, actually this one return in. So this one is in separate from everything else, right? So here your string need to be a something like an alias. Same thing, your student here need to be an alias. So here I may need to have s dot set name, and then here I have buffer. Okay, and here instead of using the string, let me do character star. Then let me see. Oh, that actually create a lot of trouble. How about this? I mean, that actually create a lot of trouble. How about let's don't do this. How about let's do string, then using buffer to create a string. Is that okay?
Yeah.
I create a string using buffer and then assign it to name. It still didn't get there. Let's do this, okay? Let's do this here. I have cls.name. Let me actually, I want to actually just try this, okay? And right here, let me try cout get name, okay? And then we will know whether it actually is actually working or not, okay? Right? This one work, right? So let's go back. Which one actually is what? Right here, the name actually, let me see here. Here say, put an X mark, okay? Here I put a Y mark. Here I put a Z mark, okay? Now let's go. Print, and I put a quiz. So XYZ all print now, okay? XYZ all print now. In that case, my X is not needed, right? Delete X. My Y is not needed, right? So Y deleted. So I keep my last one. I just keep my Z one. You know, it's kind of stupid debugging way, but it's quite safe. Bingo, right? It actually works. So here, actually, I don't need that anymore. So what it is like, you know why you definitely need that is a sign here, because if you don't assign that one, you are talking about some other S. You know, you're outside, you have a B, but here you have a S. These two are not the same one. It actually may be pointing to the subject or something, but it actually a totally different object. If you don't use the alias, actually S is pointing to another one. And then the two maybe copy the data to here. Okay, but once you create an alias, it actually is pointing to the same object. It actually pointing to the same object for S. So right here actually is what? You create a new buffer, use that new buffer to create a string, and that string assigned to S name. So S name got updated over here.
So because the input was actually not a string type?
I think so. I think the problem is like you need to convert from C string to, the input is C string. Is that okay? That's why I'm writing this, so it will make you more easier to understand. That's what I suspect. I know it already, but I just didn't get it quickly. That actually is what happened here. Actually, if you look at the CPP right here, it actually is like I create this one. So buffer is a C string, right? And then I use that to create to a list somewhere, but it's okay. In fact, I need to use that C string to do something. So right here, the same thing. I have this one is a C string. And then my C string, I need to convert it string. So the better way to convert the strings is this one can convert your C string to string, right? So remember like string unbuffer is convert C string to string. And then your n.c string is vice versa. I mean the opposite. Is that okay? So here actually up to here is fine. Okay, that's quickly continue to finish our things and then we finish the day. Okay, so that's that. The rest of them actually is quite easy since we do so many projects. The rest of them are quite easy. So let's just go over the slices. So we finished the friendship function and redirection of the the input functions. So now actually let's continue. So the next thing is like you had a global friendly function, and then this one, a plus b and b plus a. Remember a plus b, if a is polynomial, and this one a is polynomial and b is not polynomial. In this case, this one, it can be a member function if the class is on a lot, and that is a member function. So the other one, b plus a, you need to redefine again using the global function or friendship function. I would prefer friendship function because it will put into my class. You know what I'm saying? Because here, if you do my polynomial plus long integer, that's fine because it actually is the plus sign and then you just put your polynomial and the long integer there, and that actually is a member function. And if you would like to do long function and then polynomial, no way, because the first one integer is not an object, so you have to use a friendship function. Is that okay? So your add and the add in Python need to have different way in C++. Is that okay? Hello?
Yeah.
Is that okay? Because the second one, if you actually use overall a integer plus a poly, the integer is not an object. And you cannot write something like to replace that as the first parameter. Is that okay? That's
So
the only
it's
thing.
same thing as Python. So you have to make
Same thing in
another
Python, that's why you need to have the R8 or something. But Python has a standard name, but here no. You want to say?
Okay.
Overloading unitary function. So unitary can be overloaded as a non-static member function with no argument. Can overload global function with one argument. So there are 2-3 ways to do that. Okay. And remember that state function can also static data. Okay. Overload unitary data. So you actually can use this one to test the empty string. So this operator bin actually means is empty. It's an empty check for the string. So exclamation mark s means is s dot is empty. Is that okay?
Mm-hmm.
So you can use like this one to override it, or you can use a friendship function or global function with this to write it. Okay. So either way you can use that. Both way you can write it. Overloading binary operator. You can overload binary operator, non-static member function, one argument. Global function, you will need to do 2 arguments. So that actually depend on how you use it. And then if you do like right-hand side add, you need to have a binary operator and using global function or friendship function. Okay. And then overloading this one plus equal. Remember, you actually also need that. So remember, most of the time you probably need to use a alias in order to make it be able to be modified. But remember, you have to really assign the data into there.
Okay.
Okay, thank you. Bye now.
Bye.